Hey guys, Stephen here from Heresy Academy. This is the video. This video will be where we make our camera follow script, and as you see, I've just left it off here. I've not done the organising or the cleanup version of the video, stuff like that. I just want to sort of crack on with these two videos I've got. Like I said, the last one I literally recorded it like 5 minutes ago. So yeah, what I want to do for starters is bring back my project over here, project folder, drop it back to one column layout. Go to my scripts folder, and we don't really need to set anything up just yet. I will be creating two objects, which will be like the boundary, setting up the settings. The first part of this video you may have seen done before, but it's definitely worth checking it out again. Pardon me. So create a new C# script, and I'll just call this camera follow. I nearly wrote .cs there, it's not necessary. So I'll open this up in mono develop. I'm going to let it load. So we're going to use grab the transform objects, or grab 3 transforms. One of them will be our left boundary, our right boundary, and one of them will be our target, which will be our projectile. Just bring mono develop up. If it likes to play, there we go. So this one we don't need the start function. We don't need the start setting at all. We're just going to have it constantly working. So like I said, I want 3 public transforms. So I'll just do this. Don't need to name them just yet. I'll give them in a minute. Just see if I can. Oh dear. Maybe don't. Shortcuts aren't good. There we go. So the first one we'll call target. Second one we'll call our left bound. Right bound. It was supposed to be a shortcut to help make things a bit quicker, but it wasn't really that good. So right away now, like I said, I've mentioned as well, I'm going to be making this video where you can use the arrows to control to move left and right as well. So bear with me on that. For starters, we want to make a new vector 3, and we'll just call this our new position. So new pos, and this will be equal to the transform dot position. This will be attached to the camera, by the way, so it'll be equal to the transform of the position, because we're going to use the new pos, the new position, in a moment to set things up. So it's grabbing the information of the transform dot position every single update. So our new pos, new pos dot x, we only want to work with the x left and right. This will be equal to our target dot transform dot position. We shouldn't have to reference anything because I think transform still works. Then the new pos dot x, we're going to use mathf, then clamp, which if you haven't seen the breakout series, we use that to set up a boundary. We're setting this up in a bit of a different way. Very similar concept though. Like I said, we're going to use mathf, so we're using our math functions, and we're going to use a function called clamp. And then what we're going to clamp is our new pos. So this is like it says here, the float value, the float minimum, and the float maximum. So the float value is what it currently is, and the minimum is how far. In this case, it's how far left it can go, and the maximum will be how far right it can go. So our new pos, and then how far minimum will be our left boundary, and how far maximum will be our right boundary. No, not rigid body. Our right boundary. And the only problem with this at the moment is it's getting the look, we call it vector 3 here. It'll get the transform in terms of a vector 3. So we want to make sure we are just referencing just the x. Okay, so just had a little think there because I was wondering why it went red. It would completely be worth your time to add in the transform dot position dot x. Otherwise, it's not going to read the position. So I apologise for that. That was a completely silly mistake. I was just trying to rush through this. My bad. So what we're going to do after we've set this up, we want to set the transform dot position to equal. So the transform dot position of the camera to equal our new position. And that's that for making it set up so it will follow our target. If you see there, target.transform.position.x, it tries to set it there, but it's also clamped between the left boundary and the right boundary, so it won't actually just move all the time. So keep following the target, and then we want to set up the input now for our mouse. So I'm not completely sure. What I want to do is do an if statement, and I can't remember how we wrote this now. Something like if input. Let me just jump back to my notes. This was written now in the breakout game, you see. So may have done quite a bit before now. Pretty sure it's if the input is probably helps as well if we set up some floats. That might help. There we go. That's why I was confused there. So public float, and we'll just call this arrow X. Okay. Well, we don't have to do a couple. We're only using the what's it called? The mouse, the arrows. We're not using the mouse. So in the input here now, right? So I'll just comment this line. I tried to rush this out, you see. So that's what happens when you rush. Always plan, because otherwise it messes up. So I don't need to do the float now. So arrow X equals then input dot get axis, then horizontal. So you should see something similar to this now that I would have done in the breakout video. Make sure you close it off there. So now what we want to check for is if arrow X is, if it's 0, it means you're not getting an input, you're not getting anything left and right. So if I confuse myself with if input, I know that's not right. So if arrow X equals 0, I don't think that's going to work actually. Do I have to put singular thingamajig? Right. So if you've got no input there from your X, the arrow keys on the X, or the horizontal input, we'll make sure we set it to follow the what's it my doodle. Yeah, that's helpful. The what's it my doodle. Otherwise, other float I want to set up, my bad, would be a speed. Public float, we'll call this speed, not spleed. I would set that to about 5 there, just as a check up thing. So the arrow X here, every update, it's going to run every frame because it's going to keep constantly trying to grab whether or not it's being used. So if it's equal to 0 there, we'll just make sure it's follow this. Whereas if arrow X is not, it's not 0. Pretty sure I've probably written that again wrong, but I'm giving it a go. I've completely forgotten how to do this. Right. So what we also may want to do then is set up a transform. We've got transform for our target, right? So it's attaching it to our camera. Okay. I apologise for this, guys. Like I said, I've not scripted my video, so I'm just trying to run it off now real quick. So I'm going to use the transform. This is the transform of our camera, and we'll just call this cam. And this will be equal to get component, and then we'll get a transform component here. So if the arrow X is, what am I doing? Sorry, whoa. I'm all over the place right now. I wasn't very plan. This should be more organised. I'm sorry. Right, so we've got arrow x equals the input.getAccess horizontal. So we can use that to trigger those two. That's fine. Basically, like I said, if it's 0, that means nothing's happening. It's getting no information. So we'll make sure it sets up to our transform. If the arrow x is not 0, this is now where we want to sort of mess around with our camera.position. And this will be equal to, should be equal to our camera.position. Then we'll times it by, no. We'll add it to our velocity, our speed, my bad. And this will be times by time dot delta time. In theory, it should work. We'll put these in parentheses just because I want to make sure it does that first. We should still clamp it, so I'm going to go with this now. So what have I got here now? Create a float over time. So cam x. So we're using it on the x-axis here, and this will be equal to our cam dot position dot x. And then what we want to do is cam x equals our math f. Here we go. Now I think we've figured it out. Then make sure we clamp again. So you can basically just copy that line at the top there. Clamp between. Ooh, I got it. What am I doing? Oh yeah, sorry. Don't copy the line at the top. You want to use your cam x and then the left bound dot transform dot position dot x, and then the right bound dot transform dot position dot x. So I think that should work. Pretty sure. Well, we actually need to move it, don't we? So then we need our cam dot position will be equal to a new vector 3, and this will now the positions of our vector 3, the x, y, and z, will be our cam x, and then keeping it on the same one. So cam dot position dot y, and then cam dot position dot z. Yeah, Z. The reason we're not putting like zeros or ones or trying to define it there is just want to make sure it reads its own position, make sure it resets it back to what it is. We should save that now, and I do have a feeling that I may have messed this part up. If I have, then I'll just probably delete the video and forget this for now and refigure it out. Oh dear, what have I done here now? Line 18, line 23. Oh, it's not good. Right, let's just debug it. Let's see what I've done. I've probably missed out a symbol somewhere. It says it can't convert something, which is not good. Vector 3 to a float. So what's this? But our new position. Okay, hang on now. I should probably. Does that run that? No. Right, let's just leave that a second, because I may have forgot. What's this one? Well, the operator cannot be. Have I done this wrong? I think I may have actually done this wrong now. Right, so what I'll do is I'll stop the video here because, like I said, I was trying to improvise on this arrow bit. I thought it'd be really cool to do, and I do feel like I've butchered it somewhere. So I tried to sort of replicate something I did in a previous series, and it's not gone down too great. So I'll stop the recording here. I'll have a quick look around, see what I've got wrong, and I'll carry on recording from that point. Hey guys, sorry about that. I actually made the same mistake that I made in the brick break video. First of all, I missed out a very important thing here. We're using the .x. So for me it's line 18. You just want to put .x there. That will solve that issue there. So you click play again, and it goes away. Now for this one, I'll just change something. No, it's not going away, is it? Okay. What you need to do here is, there we go. Right, I wanted it to go away. So I've just done plus then the speed times delta time dot delta time. I forgot a very important thing here, which would actually be the put space there. You want to make a vector 3 and then use dot right, and then you times that by your speed dot delta time. Okay, so those are the two things I missed out there, and I actually forgot to do the dot right part in the breakout clone again. So obviously when I just ran back through my notes in my book, it wasn't in there. So very bad preparation on my half. But that's what you need to do. So to talk you through it now, we've got 3 transforms. This will be our target. Ooh, I've actually set them up in Unity already now because to test that out. So I'll still go through them though. The public float of arrow X. It doesn't really need to be a public float. I do not know why I made it a public float. I could just probably make a public float. Make a float within here, like I've done this one. Or down here. But it doesn't really matter. Let's just make it a private float though. Just to make it a bit nicer. Make sure I've not messed anything up by doing that. No, that's good. Okay, so yeah, we made a float here, the arrow X. I've called it arrow X because we're using the X position, and it's related to the arrows, just like I did in the breakout clone. We're using a speed here. Not, last time I think I actually used velocity, but velocity speed. I've set it to 5. I've made it public, and you'll see why in a minute because we can edit it. In the update then, so I've got the arrow X, which is equal to the input.axis horizontal, and then we're checking here for the value, so I'll explain that again in a moment. We're getting a transform of the camera. I'm using get component transform because we want the get component of the object of the camera that this script is going to. So we check if the arrow X is equal to 0. What I mean by that is when you click on left or right, you can give a value of 1 or -1. You're giving it a positive minus value. So when you're not pressing the buttons, the value you're getting is 0. So if it's 0, if you're not pressing the buttons, the camera will focus on the target being the projectile. And that's where we set up the new position for the vector 3, which is equal to the transform.position of the camera. And then the new position here, dot x, is equal to the target, which will be our projectile, dot transform dot position of x. And that's the bit that I missed out before. Just put dot position. You want to make sure you target in the dot x and the dot x there. Otherwise, you'll put it on the z position, the y position, stuff like that. And also, the issue that arose in the last bit of this video before I paused it is I put dot x here and I didn't there. So it's trying to get the whole vector 3. It's trying to get the x, y, and z all into this dot x, which just doesn't work. So make sure you put dot x. And then we do the new position dot x equals mathf.clamp. So this is where we give it a value, which is the new position dot x. So the value of our position. We're clamping it between the position of our left boundary, which I've already set up now, but I'll be editing and show you in a minute. And we get the transform position dot x of that, and the right boundary dot transform dot position dot x of that as well. So you set it between this point and that point. And then what we do is get the transform dot position of the camera, and it now equals the new position. So every update that you're not touching buttons, the camera will fling back to there. So if the arrow X is not 0, so it could be 1, it could be -1, we get the camera dot position. So camera is the transform is here, and then the camera dot position is plus a vector 3 dot right times by the speed times by time dot delta time. Then we get a float of cam X, and this is equal to the camera's position dot X, and then the cam X is equal to the math f dot clamp cam X left boundary dot transform dot position right boundary dot transform dot position. So very much similar to this line now. It's just basically saying this is the position of it here, and as long as it stays between there and there, it's all good. Otherwise, you can't go past it. Then we get the camera position, which is equal to a new vector 3, which is the camera X, which is everything we're changing here, and the camera dot position dot Y, so it stays on the Y and it stays on the Z. So that's what we've set up there. I've saved it. So bring it over to Unity. It'll just re-import it there. And the things you'll see that are different are the fact that I've added it to the camera. So this is important now. I've dragged the script onto the camera. So to be fair, I can set it all up again now. So I'll remove that component. I made a new object left and game object, so get rid of those two. And we'll drag you back to where you want to go, over here somewhere. I'm happy with it like that. Now, of course, when you bring in the game, this is a bit small, so maybe you want to change the size, but we can look at doing stuff like that afterwards to sort of re-edit things later. What we want to do first and foremost is get the main camera, open our script and grab the camera follow and pull it onto our camera. So now we've got 4 objects here. One is the speed, which is set to 5. We could change it to be 10, change it to be 2. We'll decide on that later. Another one is our target. So you want to go into your level 1 prefab and grab your projectile and add that as your target. So that's what it's going to snap to. It's going to keep snapping to this. Now, without any boundaries, obviously it's going to return a null value. It's basically 0, so it's not going to work. So we need to set up some boundaries. So the first boundary, I'm going to create an empty game object, and I'm going to call this one our left boundary. And what we want to do is we want to set this to the position of our main camera. So 14.7 and 3.7. So 14.7 on the X and 3.7. Oops. 3.7 on the Y. Z doesn't really matter, and the Y doesn't really matter either because we're only using the X, but I put it on the Y just for decent practices. So then what I want to do is I want to duplicate this, and we'll call it the right boundary. And I'm going to grab my camera and I'm going to pull it across my scene and see where do I want it to go. I haven't got anything over here yet, but maybe I want to add some stuff. I don't want to have it here because it will be out of the screen. So let's say it's about there. And then because I duplicated it, the Y is the same. We just want to change the X now to 77.7. So it'll be different for you depending on where you decide to put it. Then we'll put the camera back to its 14.7 there. Now back on the camera, we're going to get the left bound and I'm going to drag this in now, and the same for the right bound. And the speed is 5. Let's say we want to go for 8, just to randomise the number. So I'm saving this now, and you'll see as we start off with straight away, it's going to be limited to the left boundary straight away. It's checking out the what's it, my doodle. So I can move it with my arrow, but if I let go, it spins back. So you have to remember that. We can set something up later on if you want, or you want it like this. Went all the way to the right, and I can't get past this bit. That gives you a general idea of what's over here now. Like I said though, in Angry Birds on the mobile, you can squeeze the screen and change it a bit more dynamically, and it won't snap back and stuff like that. This is what it does at the moment because we haven't changed the snapback situation. But as well, one thing you may notice, we've not included a variable to set up for a negative input. If I just click the arrow once, watch what happens. It just shakes. Hold it down a little bit and I'll let go. For a very, very, very minuscule amount of time, it still continues a little bit. But even if I press the left arrow, it's going to the right and stuff like that. And then let go, hold them both down, let go 1, it snaps across, it only carries the 1 input, stuff like that. There are changes and edits to do for this, but I just wanted to show you how to move the camera across, and although I did mess up the script a little bit, I do feel like we managed to do it. It only took a few seconds to actually figure it out, because like, oh, that was stupid, because I just forgot the vector 3 and I just forgot to do the .x. So that's it for this video. The next one, let's see what we're doing for the next one, is our screen collider or screen limits. And yeah, that one definitely shouldn't have any mistakes, and that is actually pretty straightforward. So hope you did like this video, even though there was a bit of an issue, but hopefully there's no problems. And thumbs up if you like it. Obviously thumbs down if you dislike it, but please thumbs up. And subscribe to check out the next videos. Drop your suggestions for what you want to see. What do you want to know? Let me know and it'll be done. That's it really. Yeah, subscribe. Absolutely, definitely subscribe. Have a nice day, guys.